Hello. And first, I want to say how much I really wish that I was in Korea right now and with all of you in person. But sadly, because of COVID, I cannot be. However, we can use all of our digital technology so I can talk to you remotely. And I can talk about what I care so much about, and that is data, artificial intelligence, and networking. So thank you for inviting me to speak with you and talk to you today. To begin, I would like to start with a story. And the story is of DNA. Now, many of you know of DNA in terms of deoxyribonucleic acid. Yes, deoxyribonucleic acid was what we call DNA. The double helix structure was identified in 1953 by the academics Watson and Crick in England. And in the year 2000, about 25 nations around the world got together, of which Korea was a part, of the Human Genome Project. And the Human Genome Project sequenced all of the 3 billion base pairs in a human genome, and they did it for the first time. Now, when they did that in the year 2000, it had taken them about 13 years to do it, and it cost them roughly $1 billion. It's a lot of money. But technology has moved ahead. Data processing has moved ahead. And today, we can sequence a human genome, all 3 billion base pairs, in about a day for $1,000, for less than $1,000. So think about this. 10 years, less than a day. $1 billion, less than $1,000. It opens up a whole new set of applications, and it's going to improve people's lives. You can just think about it. Drug therapies that used to try to respond to the average person now can be tailored directly to you. But the interesting thing here is that what I'm talking about when I talk about DNA is not actually really just medicine, because these trends apply also to society and business in general. We have these new technologies to collect more data than ever before. We can process it in entirely new ways than we could before, and we can improve people's lives in an extraordinary degree. So let's think about what this new DNA looks for. And the DNA I want to talk about now is data, networks, and artificial intelligence. And if the last 20 years has been captured by the DNA of healthcare, I think the next 20 years are going to be all about data, networks, and AI. Let's start with data. Okay, so in the past, data was something that was fixed. It was sort of hardened. It was originally actually pressed into stone tablets, then it was written into parchment. And today we still write data, but we put that data or information onto disks and we put it into the cloud. And by doing so, we can do entirely new things with it. If you want to think about it in a new way, you could imagine that the data has become a resource. It has become a new raw material, a vital economic input. And that's interesting in economics because in the past, Adam Smith wrote The Wealth of Nations, he identified land, labor, and capital as the 3 factors of production. But he didn't actually think about using information as its own separate factor of production, because at the time, it was way too hard to collect it, store it, process it, and use it, and share it. But today, those constraints have largely gone away. We can do new things with data. By doing so, what we're finding is that a change of scale leads to a change in state, that this quantitative shift leads to a qualitative shift, that more isn't just more, that more is different. So one reason why we have more data than ever before is because we are able to collect more of the things we always collected it on. But another reason why is that we are taking things that have always been informational, but never data, and we're rendering it into a data format. We are datafying it, for so to speak. You could think of it as datafication. So take an example of where somebody is. Take the ancient Korean poet Choe Chi-won from the 10th century. So Korea has a great lineage of ancient poets, and Choe Chi-won, is he in China or is he back in Korea? Where Choe Chi-won is in the 10th century is a matter of information. He's in Korea. But it's not a matter of data. And you could think about back then, if you wanted to datify where Choe Chi-won was, you would have had to have a guy walk around with parchment, identifying where he is and writing in maybe in a quill, Choe Chi-won in Seoul. Right? Hard to do, not going to happen. Now think of our own lives today. We know that everywhere we are, every second of our lives is identified and is in a database somewhere because of our mobile phones. We're able to datify location. We know where objects are. We know where buildings are. We know where vehicles are. We know where we are. And that's absolutely exquisite because we can do entirely new things. It opens up entirely new services for us. But it doesn't stop there. We can actually datify aspects of our lives that we never even thought had a data bent to it. So take the example of how we sit. How you're sitting right now is all very different. No one person sits the exact same way as another because you all have different body shapes and you all have different weights. Now, the interesting thing here is if we were to take sensors and put it under your chairs right now, we could create something that looks like a fingerprint, but it's not your finger. And then what would we do with it? Well, automobile companies are thinking about using this technology as an anti-theft device in their cars. An unapproved driver goes into the seat and tries to drive off, and they're not allowed to. If you're a parent of a teenager, maybe you can think of another use of this great and wise application. You say, no, you can only stay out until midnight, but you have to be home, or if not, the engine won't run, right? You have to take an Uber. For all of these ways, we can imagine that we've datafied an aspect of life that we never thought we could before. It gets even better. What if I could tell you that using this technology, we can predict the likelihood that an accident is going to take place in the next 5 seconds? Then what we've datafied might be driver fatigue. And the car would know that when it senses that the driver is starting to slump because they're getting sleepy and tired and not paying attention to the road, maybe the car takes command and brakes gently to the side or vibrates the steering wheel or honks and says, hey, wake up, pay more attention. These are the sorts of things we can do when we datify more aspects of our lives. Now, the point here is that everything that we have around the world, absolutely everything, whether it's a light bulb, whether it's our home appliance, whether it's our car, whether it's our toilet, it's able to collect and store and process data. Now, what's the next step? Once we have this capacity to collect the data, surely the next step is that we need to use it and share it. And that's the N in the DNA, the network. Now, information in this world has gone from a stock to a flow, from something static to something that can be shared and has a sort of a liquidity to it. I remember being in Seoul about 10 years ago for a World Economic Forum meeting in which I was with a lot of eminent businessmen talking about the smart factory. And I was so excited about all the things that Korea could do to to vitalize its economy in terms of applying data to how it would actually build products and manage its processes. And I think it's a very exciting time, and there's still a lot to do. We have appliances that can access information like never before, and they can collect it and share it and then use it. And this is sort of like the new frontier, the new domain for how an equipment maker or a factory or a business will run. In the past, it was essential that we understood things like financial planning, right? Or organizational design and human resources. How do we recruit talent and retain talent? How do we actually manage our books so that we can take out loans, pay back our loans, and manage our cash flow? All of that's still important, but the critical issue now is actually not just those features of running a business, but what data do we have, what data do we need, and how can we actually bring it into a new assembly line, a digital assembly line, to combine it, tease out insights from it and produce more value from it. That network effect of information, of data, is absolutely critical. So let's think of a couple of examples. Right? So if you had a thermostat, you'd be able to identify when people are at home and when they're not. Granted, in COVID, we're all at home these days, but you can imagine that we're in certain rooms or not in other rooms. And the thermostat would know because we're actually interacting with it and might identify that people aren't here, they want the temperature warm in this room during the day, but at night they're somewhere else and they're not going to want that room heated. Likewise, you can imagine there's a toilet that warms up the seat. And that in the evening, roughly at around the same time, grandma goes and uses the bathroom and then goes back to bed. And it will know, the toilet, to warm up the seat at that particular time and then to let it cool down because it's unlikely someone's going to use it in the middle of the night. Okay. On an individual level, these are great applications. It means that you have less energy bills. It means that there's less energy used system-wide, and that's great. And you've got a great service, right? But it's on the community level that you also get these great gains when you combine it in a network. You manage the power grid better, so you're actually getting a win for the environment. And in the case of the smart toilet, that can actually see what's going on when you actually go to the bathroom and flush and maybe do some biolabs on it, looking at DNA, the other DNA. It might be able to do more than just tell you about your health. It can look at the community health. And by doing so, the community health might be in an issue of a pandemic, identifying where a new outbreak is likely to form because they're seeing a little bit of more activity in one apartment block than in another. And that can be really critical. Now, of course, we have to preserve privacy, but the issue here is that we can do entirely new things when we bring the data together, the N in the DNA. It is going to mean disruption, and disruption creates losers, and it creates winners. So it's important, as you think about these ideas, that you wonder, how can I turn disruption into advantage? How can I, as an employee, or how I, as my company, can seize on the momentum of the DNA universe and actually turn the disruption to create value for my customer, for my society, and for my business? Now, the network effect of data is a little bit like the multiplier effect in the monetary system and in banking. If you take your money and you put it in under a mattress, or so to speak, and you don't bring it into a bank, but you just sort of save it there, the value of that money just stays there and it's still valuable, but it's not being used. Nothing's happening to it. Likewise with data, if you just collect the data and you're not actually using it or sharing it and making it available, it simply stays there and the value sort of depreciates over time. It's only when it's put into a system like the banking system, but here a data system, where it's shared and used and the value from that information can be exploited and capitalized, then we get the benefits from the data. So how do we get the benefits from the data? Well, that's the third part of it, the A in the DNA, and that's artificial intelligence. AI requires data. It needs it and loves it because that's the power source of it. To understand how AI uses data, it's interesting and probably beneficial to think back to the origin of artificial intelligence. Now, dates back, the dream dates back far away, but it was around 1950 that Alan Turing wrote a paper about having a machine that could actually do the work and thinking of a human being. But the real shift, and there was sort of two schools of thought. One was sort of a logical, philosophical shift, put it on one side, of sort of creating a rule set and sort of computer code to get a machine to think like a human. Leave that aside. The real thing that happened in the 1950s, which is really more interesting, is called machine learning. And although it dates back from the 1950s, it's really only recently in the last 10 years that we're seeing the revolution unfold. But back in the 1950s, there was a computer programmer at IBM named Arthur Samuel, and he liked to play checkers. And so what he did is he wrote a program to play his big IBM machine in the game of checkers. And so he would play it, and he won. And he played it, and he won, and he played it, and he won. Because the machine only knew what a legal move was. Arthur Samuel knew something else. Arthur Samuel knew strategy. So he wrote a small subprogram that operated in the background that after every move, it calculated whether the new board configuration would likely lead to a winning board or a losing board. It's a large probability table, very intricate. He played it again, he still won. He played it again, he still won. And then Arthur Samuel left the machine to play itself. It played itself, it collected more data. It collected more data, it improved the accuracy of its predictions. And now Arthur Samuel went back to the machine and he played it and he lost. And he played it and he lost, and he played it and he lost. And Arthur Samuel had created a machine that had exceeded his own abilities in a task that he taught it. And this idea of machine learning is going absolutely everywhere. Now, one place it already went was in Seoul, Korea several years ago when the DeepMind AlphaGo program beat Lee Sedol and became the world's best Go player. It was a souped up version that used the same principle of learning from data, large amounts of data, to make predictions that otherwise would escape the human mind. But we do it in lots of other ways as well. When we mistype a name in Google, Google can identify it simply because it's scanned the entire internet and knows that instances of the misspelling are far less common than instances of the correct spelling. So it automatically corrects it for us. It's a machine learning algorithm. No one had to explicitly train it to do it this way. You set it in motion and it can make these implicit connections. Likewise, a self-driving car. To program all the rules of the road into a program is really hard because there's lots of exceptions. But if you have a machine that can make predictions, and a car is a machine, a self-driving car can make 1,000 predictions a second, you can have a car that drives itself because it can predict that this is a light, it's a stoplight, that it's red and not green. That means I must brake and not accelerate, and so on and so on. Now, the nice thing is that Korea is a pioneer in this. LG and Samsung, among lots of other companies, are actually embedding artificial intelligence in its appliances and its products. Media companies are using it as well to improve the ranking algorithms in search and making sure that it can have recommendations for products of e-commerce. These are great wins, but we're seeing it absolutely everywhere across the field. Machine learning is becoming sort of just like the microchip was for computing 70 years ago, the fundamental technology that's being put into all things to improve it and to sort of change how we interact with it for the better. Let me give you some examples. So Japan Railway is using images to find out if the track needs maintenance or if it's clear of any damage and debris. Now, you could have human beings doing this and walking the tracks, and they do that. But you can do a lot more of that review, certainly through a machine learning algorithm. And importantly, you can rank the priority with which you want a human inspector to go out and take a look at it. That's a great win. Next, farms in Israel, which I've actually visited, trundling through the soil, are using it to manage crops. They are using the image recognition of the crops to identify whether there's instances on the leaf of pests or of disease or malnutrition. And then they can manage it and identify what are the best features to get the best yield out of the farm. It's a great win for society because the only way we're going to be able to feed the planet in a world of climate change is to actually increase our yields. And so everybody wins. The consumer wins with better, fresher fruit that have less pesticides. The business wins by increasing its yield, and the earth wins as well. A great win all around. I visited a recycling center that is using artificial intelligence to identify if recyclable plastic is going along with the waste, and then a robotic arm juts out and collects it and puts it aside. Now, it can do that and do a pickup of about 60 pickups a minute, so like one a second. And what's amazing now is that we're serving the environment, but we're also not destroying any jobs because there was never an economic model to have a guy next to a trash conveyor belt putting his hand into the dirty and dangerous trash to pull out recyclable plastic bottles. You'd need a lot of people to do it. It's a hard job to do, but it's great for machines to do. So I expect a huge productivity boost throughout the economy, as well as a boost in people's well-being and welfare as we apply artificial intelligence to more aspects of our lives. Now, DNA is the sort of the substance of humankind, and it's probably going to be the substance of modern business and modern economies. Well, the DNA of data, networks, and artificial intelligence. But what's interesting is that it's not a product. It is an ingredient to a product. No one goes out and wants to buy data or buy networking or buy artificial intelligence. It gets bedded into other things, products and services that they use. It goes into goods. And why I stress that is because this is the area where Korea is extremely strong. Your economy grew unbelievably in the 20th century, one of the most impressive development stories in the world, by thinking about how you could learn from technologies overseas that have been pioneered and then bring them in and then iterate them and finesse them and improve upon them, innovate within those fundamental breakthroughs to create products and services that people love, whether it's K-pop on one side, whether it's automobiles on another, whether it's flat panel screens. Korea has been exceptionally good at being a fast follower of implementing breakthrough innovations and therefore inventing and innovating itself. And by doing so, the race will be on, because you may have AI engineers at the cutting edge in Europe at Facebook and at research labs, and in the UK at DeepMind and at Google. And they might be doing the academic work. But if Korea is really wise, it will be able to see what's going on and build the products, embed them into the products that people want to buy, that will improve their lives and improve society at a time when we all are working from home and are looking for companies to provide us the security and simplicity that we all need to change our lives at a time of a pandemic, and also in the post-COVID era, in which the hybrid economy of working remotely is going to be a feature of all of our lives. And the way that we interact with our digital devices is going to become more important than ever, and we'll want them to tailor around us. And that is what AI promises to do. It will tailor these technologies to people. So the race is on. You have Japan on one side that's aiming to do something similar, China on the other, and a huge market around the world that is looking to Korea and Korean companies to pioneer these technologies. I am so pleased I can talk to you about them, because I really believe the opportunities are great for absolutely everyone, for the consumer, for the company, and for the country. I'm really pleased that I had this opportunity to talk to you about my love of all things DNA, and I hope that the next time I'll be in Seoul, Korea with you to talk to you directly. Thank you very much.